The title of this presentation is Cubefly, Drone Mission Planner and Photogrammetry Software. Cubefly is a solution to manage UAV photogrammetry applications. Thanks to this software, it's possible to plan missions and post-process the data that you acquired during the flight. This is not an acquisition software, so Cubefly is not a flight hub. If you want to fly, you need your own application on your device that you connect to the controller, to the UAV controller. But Cubefly can plan missions, selecting the area that you want to survey, selecting the type of mission. It's possible to choose between several mission types, normal missions, vertical missions, and so on. In the software, you define the UAV model, and so defining the UAV model, you actually define the sensor type. And in that way, the software will know the parameters of your camera. During the mission plan, it's also possible to consider the elevation of the survey area. And so choose if you want to follow the terrain or not. Of course, this mission that you planned, it can be exported, and after you exported it, you will load it on your own app. You go in the field, you survey flying with the drone and collecting some ground control points. When you go back in the office, you do the post-processing. So in the software, you import the ground control points measured by a GPS, and you import the photos that the drone took. And then, from this information, the software can build the 3D model. So you can create dense clouds and meshes. It's also possible to create the orthophoto. And from the point cloud, you can have a virtual survey. So directly on the point cloud, you can define points, polylines, and create contour lines. Let's start from the beginning, from the drone mission planner. So the first step in Cubefly is, of course, define a project. And then you can start with the definition of the mission you are going to survey in the field. The mission can be created from this tab, where you see you can define the type of mission, choosing between several types of missions. So, for example, this is a normal mission, but if you prefer, you can create a grid mission. So, a grid mission is like two normal missions intersecting together. Otherwise, if you need to survey embankments, roads, you can need to create a linear mission. And so you simply define the path of your road, and automatically the software will calculate the mission. Again, there is also the possibility to define vertical missions. And so this is very useful if you need to survey building facades. You simply define the limit of your building and the height of your object, and the software will define a vertical mission. And then it's also possible to define a circular mission. So simply choosing the center of your object and a distance, the distance where you want to fly, and the height of the target, you define a circular mission, which can be very useful to survey towers or a tank. After the mission type, you have to define the UAV drone. In the software, there are already listed many UAV models. The DJI models are all available, but there are also some other brands. And then there are all these parameters. So these parameters change a little bit depending on the mission type. Here we have a grid mission, and so we have to define certain parameters, more or less are the same for all the other missions, but something could change. In any case, it's important to define, of course, the overlap, the frontal and the lateral overlap between photos. So how much I want that my photo is overlapped to the next one and to the lateral one. Then you can choose to modify the angle, so it is the direction of your mission. The extra wide, so how much you want to go over the limits defined from the area. And increasing the extra wide, it means that also the boundaries are surveyed better. Then it's very important in a grid mission and also in a normal mission, define the ground distance. So how much is the fly height? Defining these parameters, the last parameters, the last rows are in gray because they change, they are not user-defined parameters, and but changing the first parameters, they also are modified. And in the lower part of the screen, you see that you have a preview of other parameters. For example, the ground pixel size, that is very important. In this way, you already know before going to survey, before going into the field, how much could be your resolution. The mission is created, and now it's time to export it. But before exporting the mission, there is still one step that you can choose to perform or not, and it is the use of terrain models to consider the path of your field. So if you work in a very slight terrain, it could be very necessary to consider the terrain behavior, And this terrain behavior can be calculated by using some terrain models, which could be the SRTM model or Google model. Otherwise, if you have your own model, maybe coming from a previous survey or coming from some regional website, you can load it and use this DTM as input. You see that once you consider the terrain model, you have a preview of which will be your mission. You see in the lower part of the screen the mission that is in green follows the terrain, which is in blue. Now it's time to export the mission. You can choose to export by using different formats and defining some parameters like the finish action for at the end of the mission. You say, I want that my UAV drone comes back to home. Why it's important plan a flight? It's important because you increase the acquisition quality. Of course, as first, you can manage the regularity of shots and coverage thanks to the definition of the overlap between photos. But it's also a good solution because you use a DTM model. So consider a situation like in the drawing on the right. You see there is your UAV drone flying always at the same height. Look at the red line. It takes pictures, but the terrain is not flat, and so the pictures for the first shot is took at a lower distance with respect to the second shot. It means that at the end the 3D model will have some irregularities because the ground sampling distance is not the same. So it's very important in some conditions consider the digital terrain model. Another good point to plan a flight is an estimation of control points, ground control points, and an estimation of how much will be the time for your work. So that's why it's important plan a flight. Now we have exported our mission. We load the mission on our controller. We go in the field and we collect some ground control points. So we set in the field some targets before flying with the UAV drone, of course, because these targets must be visible in the photos. To collect the ground control points, you can use Cubefly software, which is a Android software, and it is integrated with Cubefly. So in that way, you have a direct import in Cubefly when you go back in the office. On the right, you see that we collect several ground control points to cover all the area. Then you start with the fly. We used during this survey the Litchi app, but from the software it's also possible to export native formats for red waypoint and unique as well. Otherwise, if you have other applications, maybe you can import the mission by using the KML or the CSV formats. So from the app, you simply tap on a play and the mission starts and the drone flies by itself. During the flight, you can take a picture at the takeoff point and measure it by GPS, because if you take a picture while the drone is taking off, you can shift all the images with respect to these coordinates. So from the picture at the takeoff, you have some EXIF coordinates inside the picture. You have the coordinates that you measure by a GPS, which of course is more precise. And in the software, when you will post-process all your data, you will use this takeoff photo to shift all the other photos. And in this way, it's easier refine marker position. You can refine all the other ground control points quicker, because the target is nearer the correct position. So after the survey, we go back in the office, we open Cubefly, we import the ground control points that you see in the image and the photos, and then you have to start with the ground control point definition. So you have to refine the marker position. You can see in the image you have a photo where you see the target, and clicking with the mouse you refine the target position on the photo. You have to do this operation for several photos, but thanks to the shift we performed by using the takeoff photo, this operation is easier. And then we have to build the 3D model. So from this page you define the parameters that the elements that you want to use to align photos. So if you want to use or not the EXIF and the ground control points, and you choose which are the results you are interested to. So dense cloud, orthomosaic and mesh. And for these results you can choose a quality. Once that you have run your after the software has built your results, you see that opening the result folder, you already have saved all your data. So you already have in the folder the point cloud, the mesh, and the orthophoto. You see the result. As outputs, you have a sparse point cloud, a dense point cloud. If you choose, you can have a mesh with texture and an orthophoto. Here you see, this is the same model. On the left you have the point cloud, on the right the mesh. Last step, if you are interested to, you can have a virtual survey on the point cloud. It means that you can measure points, create polylines and contour lines, and all of them can be exported through the DXF format. Now we see that the Cubefly can be, the results of Cubefly can be integrated also with other sensors. So here we have the point cloud coming from Cubefly, you see. In this other tab we have the point clouds coming from a laser scanner, our Stonex X300 laser scanner. There are 10 scans. Then I merged together these 10 scans and created this X300 union. Now I load this X300 union on the survey made with the Cubefly. And so you see that these two data can be combined together, and this is a big advantage, because maybe with a drone you can have a better restitution for the field, while by using a laser scanner you have better results for the vertical parts of the query. You can use this software to work with lens slides stability applications. So if you need to survey lens slides, it could be a very good solution, thanks to the use of a DTM. Other applications may be the mining queries, can be the survey of buildings, so for architecture, for rendering of building rendering, to survey in the topography applications, for cadastre, for urban planning, precision farming, and also if you need to survey landfill, it could be a good solution in the waste management field. Thank you for your attention. And if you have any question about our products, you can reach us here at intergeo@stonex.it.